Merry Christmas. Oops, I'm out of focus there. All right, this is going to be a brief video on an ohm meter, how I use mine on a regular basis. So first, a brief tour of the meter. We have volts, ohms, conductivity, it's a diode, capacitance, and amps. This little sinusoidal symbol, squiggly line, is alternating current, AC, coming out of your wall. And a solid line over some dashed lines is direct current. You'll see some of these, they're saying, okay, for this setting, either alternating current or AC or DC is acceptable. Here, not. You'll notice there's 3 holes down here. Black always goes into COM. Red, well, you see all these symbols here, are all these symbols here, except for this last one. So the highest amperage setting. So if you're going to measure for amps, you always start off here on the largest amp setting, and if you read 0, then you switch over to here and you go down 1 and you start measuring that. But we'll get to that in a second. So the first thing that I use this for regularly, which I actually used this week, is my Christmas lights stopped working. So if you go to conductivity, it's like this little Wi-Fi symbol. I think yours is down here somewhere. Just this guy. It's sound emitting. That's what the symbol means, because if there's a connection, we get a beep. That's it. What do I use this for? My Christmas lights stopped working. After I made sure that they had power, I opened up the plug and I found this, a fuse. This will work for fuses in your car, fuses in your microwave, fuses in your computer. There's fuses everywhere. And if it's a good fuse, it should allow current through. But once it's overloaded, the fuse is damaged and current no longer gets. So I grabbed this out of my Christmas lights and I got no beep. So I know that this fuse is bad. No beepy, bad fuse. This alone makes this thing invaluable. I've found things don't work, it's a fuse. And now I know, because I didn't get my beep. The second thing that I use this for is testing batteries. So you'll see 1.5 volts. So I can test it, take this and set it to DC volts. And 1.6. So this is brand new. So it always comes with a higher load than it's rated for right out of the package. And I just positive red, negative black. I don't know if that's common knowledge. By the way, if these are switched and I accidentally put my red to negative and my black to positive, I get negative 1.6. So if you ever get a voltage that's negative, it just means that your positive and negative are switched. Now, measuring batteries can be, there's a disclaimer, because sometimes I'll measure a battery and it'll, oh, by the way, different devices require a different charge. So something like your mouse might work with a battery that's at 1 volt or 1.1 or 1.2, but something, or a remote or something that requires more energy might stop working at 1.4. The other disclaimer is that sometimes an old battery will still have a good charge and its voltage drop is 1.5 or 1.4, but it has no current, so its ability to hold a load is gone. So you can measure the current. Now, if we did this the right way, we'd start with this guy here and start on the highest setting. But this is like the 5th take for this video. So I already know that this battery, one by itself, isn't even going to measure anything on the lowest setting. So what I'll do sometimes is I'll take 2 brand new batteries and I'll put them together, positive to negative and so on, and test the current. Hey, I got 2.1 microamps. And then I can take the suspect battery and put it with one of these good batteries and see if I'm still getting a good current. If I'm getting less than half, then the battery's no good, even if it's reading 1.5 volts. Finally, the last thing, which this is also something that I've done that's happened to me, is my laptop stopped charging. I thought, hey, what the heck is wrong with my laptop? So, first thing I did is make sure that the plug that I'm trying to charge is working. So I set it to volts, AC, squiggly line, and got to be careful when you're doing this. You definitely don't want to touch those two together or you'll break it. But look, 123. So I know that I'm getting juice. So now my charger. What about this? How do I test this? Every electronic device should have a label on it. This is a nice label because it's white, lettering's big. A lot of them will be embossed and it'll be the same color as the plastic. Really hard to see. Or really small. This one's good, but these labels are great. I like to read them for fun. There's so much good information on them from an engineering perspective. You can see we got inputs, outputs. Our input, 120 to 240 volts. Interesting. We could plug this into 220. Look, our squiggly line, AC, so our input comes from the wall. 60 hertz is standard in America, 1.3 amps. Output, 19.5 volts. DC, it's a solid line over the dotted line, 2.31 amps. Hey, how do we go from 1.3 amps to 2.31? Ohm's law. But still, what are we going to do about this? Well, that's on here too. Look. It says that the outer edge of this thing is negative and the inner edge is positive. So the outer edge is negative and the inner, which is a little pin you might be able to see in there, is positive. So negative, positive. Oh, it's set to AC. I gotta set it to DC. Yeah, 20 volts, so it works. But as it happens, I had a charger. If see that says replacement, because my old one stopped working. Something inside here went, probably a fuse or something burnt out, so it no longer worked. I could have taken it apart, but that was less than $20. So there's 3 things that I use my ohm meter for on a regular basis. Now, a couple more cool things I'll show off since I have you here. This is my telescope, which I love. I've seen Venus with this thing, and it was amazing. This is a parabolic antenna that I'm building. I'm going to interface with a satellite and grab some pictures of Earth from outer space. This was Jane's birthday present to me. It's a puzzle. It came unbuilt. It was a bunch of wood pieces that are in these sheets that I had to pop out. And Pretty cool, huh? And finally, this is something that I've been working on. Here's the schematics of this circuit, if you care to replicate it. It's this here. For reference, this here is some old wire from some old Christmas lights here. And this is an RCL circuit. L, inductor, C, capacitor, R, resistor. In this case, our load, our resistor, is going to be a LED light. They're soldered together in parallel. Now this may look like a battery, but it's not. It's an inductor. So if I cut this shrink off, it's just some copper wire wound around a little post. Just copper wire. No battery, no power source whatsoever. All right? Observe. Merry Christmas. Winter, say Merry Christmas. Timber, Merry Christmas. Merry Christmas.